Hello everybody, Mrs. Avon here. Tonight we're going to talk about circular motion and inertia. We should remember that inertia is the tendency of an object to remain in its state of motion. And we can very easily see that if we take a tennis ball and place it on a whiteboard. On the left side of the page, the tennis ball and whiteboard are initially moving in a straight line. Then the whiteboard begins to follow a curved path. In order for the tennis ball to stay in that curved path with the whiteboard, there has to be some kind of barrier there. There has to be a force generated by that barrier that causes the acceleration. Newton's second law says that we have to have a force, an unbalanced force, in order to have acceleration. So on the right side of the page, we remove the barrier. The whiteboard is being accelerated. It's moving around a curve. But there's no barrier, no force provided to keep the tennis ball moving with the whiteboard. So it follows a straight line path. We call that its inertial path. If we look at this as a series of photographs of the whiteboard moving, you can see that the red line on the left, or the red circle on the left, shows that the whiteboard is moving around a curve. But the tennis ball is continuing in its straight line motion, which we call its inertial path. Because another way to describe inertia is to say that objects keep on doing what they're doing. The tennis ball was initially moving in a straight line. There is no unbalanced force because there is no barrier in this picture. Therefore, the tennis ball will continue to move in a straight line. If we look at the picture on the right, we can see that if we want that tennis ball to follow the same path as the whiteboard around the curve, there has to be a force applied. And if you look at the blue arrows, the direction of the force, it is always inward, towards the center of the circle. So we introduced this in video B, but what do we call that force? Is it called the centrifugal force? Centrifugal with an F. The answer is no. The force that causes circular acceleration is called the centripetal force with a P, not with an F. That means center seeking. Centrifugal force is very often used to describe a sensation of something being pulled outward, but that force doesn't actually exist. So we have to be very careful when we're talking about the force that causes circular motion. The physics classroom actually calls the term centripetal the forbidden F word. It does mean outward because there is a sensation when you're on a reference frame that is accelerating. For example, if you're in a car that's making a turn, you feel like you're being pulled outward. So that sensation has been given the term a force. It's not a force at all. It is just a sensation that is caused by inertia. So I want you to think of the word centrifugal as the forbidden F word. Don't use it. The correct term is centripetal, as you saw in the last slide, because it is center seeking. So just be very careful when you're answering questions about the force that causes circular motion. It is the centripetal force, and do not use the forbidden F word. The centripetal force is not a new force that we're going to add to our list, but rather it describes the direction of familiar forces that we've already been using. We know from previous videos that the term centripetal means center seeking. What we're going to see are various examples of friction, normal, tension, weight. The forces that we're already familiar with, those are going to be the cause or the agent of the centripetal force. Centripetal, again, is just a descriptor that says one of these common forces that we've already learned about is directed towards the center of the circle. So our first example is if we have a car moving around a curve or driving in a circle. We know there's a normal force, we know there's gravity, but there is also friction. And in this case, friction is directed towards the center of the circle, because anything moving in a circle has to have an inward directed force that we refer to as the centripetal force. But friction is the actual force that causes that inward acceleration, and that is that inward net force. We can also look at being at the bottom of a loop of a roller coaster or the top of a loop of a roller coaster. If we were to take the picture on the left, the bottom of the loop, and continue to draw a circle, we can see that the net force has to be upward because that is towards the center of the circle. That means the normal force has to be greater than the gravitational force, because towards the inside of that circle is the up direction. On the other hand, on the right side at the top of the loop center, or the inside of the loop, is where our forces have to be directed. So normal and gravity have to both be directed downward. On the left, at the bottom of the loop, the normal is directed upward. So on the left, you can see visually that the normal is greater than gravity in order to have an inward or centripetal force. And on the right side at the top of the loop, both normal and gravity are both directed downward. You can't really tell the magnitude of the normal force when you're at the top of the loop unless you know the acceleration. When you're at the bottom of the loop, you can simply tell that the normal force has to be greater than the gravitational force. So what we're going to be doing is start applying what we know about forces to circular motion. Another common example is a rotor ride. They used to have one of these at Kennywood, but they took it out. What you see is people being stuck to the walls of a rotating drum, and the bottom drops out. You actually have some people that are upside down in this picture. What happens here is that you have gravity acting down. You actually have friction working upward that's keeping them from sliding down the hill, but there has to be something that is coming from the surface of the drum pushing inward, because anytime there is circular motion, there has to be an inward or centripetal force. So what do we call the force that is perpendicular to a surface? We call that the normal force. So the normal force is what is causing that centripetal force, that centripetal acceleration. So when we go to analyze motion in a circle, we're not really adding another force. We're saying that one of the forces that we already know how to use is the cause of the centripetal net force and the cause of the centripetal acceleration.